I welcome you all to my class. I'm Miss Vandana Gupta, Assistant Professor of Mathematics. So today we are going to study time series and index numbers. This is unit 4 of statistics, that is section 2. So we are going to start with time series today. Now what is a time series? See, when you arrange the data as per its happening or as per the time when it occurs, then the resulting data or resulting series is called as a time series. So how we define that? A time series is a sequence of values of a phenomenon arranged in order of their occurrence. We can have many examples of time series. See, in time series, we are arranging the data as per the time. So that time could be either year, it could be month, it could be week, day, or maybe hour also. So examples of time series. A shopkeeper may want to analyze the sale of, say, mobile phone in his shop monthly. Okay, so that time series can be written as, in the first column you will write the month, and in the second column the sale. Okay, sale of anything. So here the time is month. So in Jan, Feb, up to March, up to December. The sale in the months. Okay, so this could be an example of a time series. You may also have the second example, in which a college would like to analyze the strength of its students yearly. So year and number of students. So say start from 2001, 2, 3, maybe up to 2020. And these are the figures. So these are the examples of time series. In this, time is year. In this, it is month. You may have another example. Say daily price of a particular share of a company, shares of a particular company. So here the time will be day, every day, and here the share price. Okay. So daily shares price of a particular share of a company. So this again will be an example of a time series. Again, you may have another example of time series where the time is hour. So you may have another example where it is hour. And you may want to see the temperature in Mumbai city. What was the temperature at 12 a.m., 1 a.m., 2 a.m. So it is giving you the time series where the time is an hour. Okay. So in this way, you can give plenty of examples of a time series. Everywhere the data is written as per the time. Okay. Now, why you want to study time series? The analysis of time series is required for making future prediction or for forecasting, so that proper strategies can be planned. Now, there are various factors which are responsible for the time series, for the values in the time series. So these are called as components of the time series. So what are the components of time series? The factors responsible for the variations in the values of the time series are called as components of the time series. There are following 4 components of the time series. First one is called secular trend. Second one, seasonal variations. Third one, cyclical variations. and 4 irregular variations. Let me explain you one by one. So the first one is secular trend. See, the general tendency of the data is either to increase or to decrease or to remain constant. So that is called as a secular trend. It is smooth and long-term movement of the data. The changes in the values are gradual and continuous. You can see the example of secular trend as if you see that the demand of mobile phone, it is increasing over the years. Similarly, the demand of luxury items like TV, fridge, washing machine, uh, home theater. So more and more people are buying every year, okay, luxury items. So the demand of the luxury items is showing an increasing trend. So if you like to draw the graph of that, it will show you an increasing trend. Okay. Similarly, we can have the time series where it is showing the declining trend, decreasing trend. The example, you can see that the death rate of infants is declining. See, you can see that 20 years back, the death of infants were more, but now because of the good medical facilities, even in the remote areas, the death of infants is decreasing. So that is showing a declining trend. Also, you can give an example where the import of food grains in India, that is also showing a declining trend. Okay. So these are the examples of secular trend. Either it will, on long time, it will show an increasing trend or a decreasing trend. Second one is seasonal variations. You can see that the sale of certain items that increases suddenly during a particular time, during a particular season. So there will be a variation in the time series during that period. Okay. For example, the sale of woolen clothes will definitely increase in the winter months. Similarly, the sale of raincoats and umbrellas will increase in the rainy season, in the month of June, July, etc. Okay. And it also depends upon the place. Okay. So there will be the variation as per the season. Similarly, you can see that the sale of firecrackers, it increases during the festival season. So that season's value is going to affect the time series, that particular season. So these are called the seasonal variations. Then the third one is cyclical variations. These are the changes in the time series occurring over a period which is more than a year, and they are recurring and periodic in nature. And the period may not be uniform. So these fluctuations are due to the changes in a business cycle. Say there are 4 phases of a business cycle. The first phase is the prosperity, in which the profit is increasing. Then comes a maximum profit, the peak period. And after that, there is no more profit. So that is called the recession period. And then there is a depression. Suddenly, there will be a decline in the profit. So it's a depression period. And then again, it will start recovering. So that is a recovery period. So it gives you a cycle, like it is like that. When you start the business, there is a profit is increasing, prosperity. Then there is a recession period, it is constant. Then there is a decline. And then again, there is a recovery. So this way, it is like a cycle. So, these the various phases in the business cycle also affects the time series. So these are called the cyclical variations. Fourth one is irregular variations. The changes in the time series which cannot be predicted. or which are erratic in nature are called as irregular variations. What does this mean? See, you cannot predict that there will be a flood tomorrow or there will be a cyclone or storm. So there can be some natural calamities due to which the uh, values in the time series may be affected. If suddenly there is a flood or tsunami or whatever, any natural calamities, then it may affect the sale of a particular product. Okay, these are called man-made calamities. There can be natural calamities. There can be man-made calamities also, like there could be a lockdown or there could be a strike or maybe curfew is imposed in a certain area. So due to those irregularities, the values in the time series may be affected. So these are the four components of the time series which can affect the values in the time series. Now, as I told you that the time series is used for prediction, okay, for forecasting. So how to do that forecasting? What are the various methods to do the forecasting? These are called as to find the trained values. So, or the estimation. So estimation of trained values in the time series. There are the following two methods which are there in your syllabus to estimate the trend values of a time series. First one is called moving average method and the second one is called as least square method. So today we are going to study moving average method. In moving average method also there are three types. One is 3-yearly moving average method, second is 4-yearly moving average method, and third one is 5-yearly moving average method. So I'm going to explain you this with the help of one problem. What is 3-yearly, 4-yearly, and 5-yearly? In these moving averages method, we find out the estimated trend by taking the average of the current year value, previous years, and the next years. Okay, let us see the example. So let me explain you in front of you only. So we will have a time series here. Find 3-yearly moving averages for the given time series. So let us first see how to calculate 3-yearly moving averages. So let me give you the time series. Here in this time series, the time is year. So year and the you can say the production of certain product, certain goods. Okay. So production in the second column. So suppose my years are 2001, 2002, 2003, 2004, 2005, 6, 7, 8, 2009. And the figures are given as the values of the production 62, 63, 66, 65, 68, 70, 73, maybe 71, and you may have here So these are the values for your production. Okay. These figures may be in thousands of rupees, or you can write production in thousand units. Production in thousand. So all these figures are in thousands, 62,000, 63,000, and so on. Okay. You have to find out 3 yearly moving averages. In this method, what we do, we calculate the average of the current year, the value in the previous year, and the value in the next year. So what we will do, we'll make the two columns. So this is the time series given to you. So in the column which we have prepared, we'll write 3 yearly totals. 3 yearly totals. And then in this column, 3 yearly averages. Okay. So I'm given the figure for 2001 production is 62, 2002 63, and 2003 66. What I will do, I have to find out the 3 yearly averages. So I have to take the first I have to take the sum of the first three. As I told you, while taking the average, what you have to do is you have to take the average of the current year, the previous year, and the next year for calculating the for 2002. For 2001, I cannot calculate because I don't have the value for the previous year. So for this, I cannot calculate. I'll put a blank. What I will do for 2002, I can do. I have to add these three values, 62, 63, and 66, and divide by 3 to get the average. So add 62, 63, and 66. So what you will get, 62 plus 63 plus 66. That will give you 191. So you will get the total as 191. You want average, so divide this total by 3. So you will get 63.66. So let me write 7. Okay. Now, so this is the average for the year 2002. Now I have to calculate the average for 2003. So what I will do, I'll take the average of this value, the previous one, and the next one. So the average of these three. So what I have to do now, I have to add these three numbers. 63 plus 66 plus 65. 63 plus 66 plus 65. That gives me 194. Okay. Divide by 3 will give me the average. So it is 64.66. So I'll write 64.7. Okay. So I have calculated the average for 2003. See, the actual value was 66. The average is coming as 64.7. In this way, you keep on moving from top to the bottom of the table. And that is why it is called the moving average method. Now for the year 2004, if I have to calculate, I have to take the previous value and the next value. So now I will take the average of these three. I leave this 63. So 66 plus 65 plus 60, that gives me 191. Okay, and divide by 3 will give me the average, that is 63.66. So it is 63.7. The actual value was 65, but the average of 3 years is 63.7. Okay. Now for the year 2005. So I have to leave this 66. I have to take the average of 65, 66, 60, and 70. So add 65 plus 60 plus 70. That gives me 195. Sum of 65, 60, and 70 will give me 195. Divide by 3 will give me the average. So that is 65. Okay. Now the next one. So I have to do for 2006. So I will leave this 65 and take the sum of these three. 60 plus 70 plus 72. That will give me 202. Okay. Divide by 3 will give me the average, that is 67.3. Okay. Now the next one. For the year 2007 means I have to leave this 60. I'll take 70, 72 and 68. So 70 plus 72 plus 68, that gives me 210. Divide by 3 will give me 70. Then the last, for the year 2008, I have to take the sum of 72, 68 and 75. So 72 plus 68 plus 75. That gives me 250. Divide by 3 will give me the average value, that is 71.66, that is 7. Okay. And for the year 2009, I cannot calculate because we are not having the value for the next year. So for the last year, I cannot calculate. Okay. So this method has got one disadvantage, that I cannot find out the trend value for the first and the last year. Okay. So what we did to find out the 3-yearly moving average method, for the first one, you cannot find out. Take the average of these three values. So first take the sum, divide by 3 will give you the average. So first these 3 values and write down that in the middle, means this value, this average will be for the year 2002. Then leave this, take the next 3, 63, 66 and 65. Sum is 194, average is this. Then leave 63, take 65, 66, 65 and 60. Take the average of these 3 and write down the value here. Then for 2005, take this. So in this way, leaving one value from the top and coming to the moving from top to the bottom by taking the average. Okay, so that is how you get the 3-yearly moving averages. Now these values you can plot on the graph paper. Okay, so let us see how the graph, from the graph you can see the trend and the estimated, the original time series and the estimated values or the trend values. So let us see how we do that. I don't have the graph paper, so I'm just going to roughly show you. So plot the graph of the original time series and the trend values. So we'll do it here itself. So plot the graph of the original time series and the moving averages. So what we do here to draw the graph, this is my y-axis and this is my x-axis. We only want a rough idea. So the actually, if you do it on the actual graph paper, then you can, the scale will be proper there. Here we will draw it roughly. So on the x-axis, we will draw the year. What are the years? From 2001 to 2009. So I may take it here, 2001, here, 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008 and 2009. Okay, 2000. Okay, on the y-axis we have to plot these sale, okay, production values. So it is from 62 to 75 is the last. Okay, so we can have 60 is also there, 60. So we can have 55, 60, 65, 70 and 75. This is how I get it. It is as per the availability of the graph paper. You may take the scale. Now first we will plot the trend values. Okay. So for the year first we'll plot the original time series. So for the year 2001, it is 62. So for 60 is here. So 62 will be 60 is here and 65 is here. So 62 will be somewhere here. So I'm roughly drawing it. 2001 for it is 62. So somewhere this point will come. Okay. 2001 it is 62. Okay. For 2002 it is 63. 2002 it is 63. So slightly above. Okay. For 2004, 2003 it is 66. For 2003 it is above 65. So it will be somewhere here. Okay. 2003 66, 2004 65. For 2004 it will be 65. Okay. 2005 60. For 2005 it is 60. Yes, 60. 2006 70. 2006 it has gone high, 70. 2007 72. 2007 72. And 2008 again it has come down. 2008 68 means somewhere here. 70 is here, so 68 will be here. And 2009 75. 2009 it is increase again and it is gone here, 75. So these points now we are going to join. So for the year 2001 it was 62. So this is 62. 60 is here, so see. Then we'll join this for 2002 63, 2003 66. So 66 is here. Then 65 here. Then 60 here. Then 70, 70. Then 72. Then 68. And then 75. So we will join all these points. Okay. So you can see from the graph that from 2001 to 2004, there was an increase in the production. देखो 1 से 4 तक 62, 63, 66, 2003 तक increase था. Then 2004 में 65. See, look at here. 2004 65. It has come down. Okay. 2004 में it has come down. 65 हो गया. फिर again it has come down in 2005. 2005 में it has become 60 here. 2006 में again it has jumped. It has become here 70. Okay. Then 2007 में 72. Again it has increased. After 72 again it has declined. Maybe for various factors 68 and then 75. So you can see that from the graph you can see the pattern of the time series. It is increasing here, then decline, then again decline, then increase, then increase. Okay. See here you can see. It has increased up to here 2003 तक increase हुआ, then decline, then again increase, then decline, and then again it has increased. So you can see that the you can plot the graph like this, and that will give you the pattern of the time series. Now on the same graph paper you can plot the moving averages. So I'll use the different color for that. Maybe I'll use the red color. So for 2001 I don't have the value. 2002 ke liye it is 63.7. Means for 2002 it is, before it was 63, now it is 63.7. So I can call it as 64. So it will be slightly up. 2003, for 2003 it is 64.7. So 2003 before it was 66, now it is 64.7. So it has come here. 64.7 here. So I will join these 2 points. Okay. Then 2004 it is 63.7. So it is again declined. 63.7 matlab 64 you can say. So it has declined again. Then for 2005 it is 65. So 65. For 2006 67.3. 67.3 means it has again gone high. 67. 2007 it is 70. For 2006 it is 67.3. And for 2007 it is 70. So it is like this for 2007. Here 70. And then 2008 it is 72. 2008 it is 72. So it is again increased 72. So you can see that with red color what I'm doing is these values I'm plotting. Okay. For 2002, it is 63.7. So I may call it as 64, round it off. Okay. So for 2002, it is 64 here, this point. Okay. So if you have a proper graph paper, you can do it. So for 2002, for 2001, I don't have the value. For 2002, it is 63.7, means 64. So for 2002, it is 64, this point. Okay. Then for 2003, it is 64.7. 2003, 64.7, matlab 65, I can take here, this value. So I have joined these 2 points. Then for 2004, it is 63.7, matlab 64. So 2004, it is 67. It will come 63 here. Okay, down. Then 65 for 2005, it is 65. Then 67.3 here. Okay, then 70 here, and then 71.7 here somewhere. Okay, so you can see the original time series as well as the moving averages. And then you can write here on the top of your this one, that this is the moving averages with red color, moving averages. Okay, and the black one is, wait a minute, on the top right corner of the graph, you can write down the black one is original time series. Original time series. So the one which is shown by the black color is the original, and which is shown by the red color is the moving 3-yearly moving averages. So in this way, you can plot both the time series on the same graph paper, and from the graph, the pattern of the graph, you can make out. Okay. So today we have seen how to find out 3-yearly moving averages and how to show them on the graph paper. In my next lecture, we will see 5-yearly and 4-yearly moving averages. So thank you all.